Hello everyone, my name is Sahil Kaler. I am pursuing BTech from IIT Roorkee. So today we will be doing writing a CPP code to find whether a given positive number is twin prime or not. Our objective is to find out whether given positive number is twin prime or not. So first of all, we need to understand what are the twin primes. So twin primes are the prime numbers which differ by two. Twin primes are basically the pair of two numbers and both of the numbers have to be the prime numbers, and both difference between the those two numbers has to be 2, like 5 and 7 are twin prime. 5 and 7 both are prime numbers, we know, and difference between them is 2, so they satisfy the condition of twin primes. So logic will be logic behind the our code will be to find whether a given number is twin prime or not. We need to find whether a given number is prime number or not, because twin prime is the greater restrictions on the prime numbers. So we will find whether the given positive number is prime number or not. First, we will try to find whether the given number is prime number or not. If the given number is not prime, that means it cannot be the twin prime number, that it cannot be a twin prime number, because the twin prime numbers are the prime numbers which differ by the two. Else, we will check for the primality of n plus 2 and n minus 2, because the twin primes are the numbers which differ by 2. So if n is a prime number, then we will check for n plus 2. If n plus 2 is a prime number, then n and n plus 2 will form a twin prime pair. If n plus 2 is also not prime number, then we will check for n minus 2. If n minus 2 is prime number, then n minus 2 and n will form the prime twin prime pair. If none of n plus 2 and n minus 2 are prime, that means they are composite number, then what can we infer from this, that n is a prime number but it is not twin prime number. So for this we need to write a code to find whether given number is prime number or not. So we will writing a primality test whether a given number is prime or not. We will define a function p by n. I have just for its personal choice what name do you want to give to your function. I have given p by n because p stands for prime, y for yes, and n for no. Whether the given number is prime or not. This function will return 0 for the prime numbers as input and 1 for composite numbers as input. So if pyn of 7 will be 0 according to this definition of pyn, and pyn of 8 will be 1 because 8 is a composite number. 8 is divisible by 2, so hence it is a composite number. Then how we will proceed if, okay, we have defined the function pyn. Now how we will proceed if we will first check for the pyn of given number, means if pyn of given number is 0, then we will check for pyn of n plus 2 and n minus 2. If pyn of given number is 1, that means given number is composite number, so it can be prime. If pyn of given number is 0, that means given number is prime number. So we will check for the primality. We will check whether the n plus 2 or n minus 2 is prime number. So how we will check whether n plus 2 or n minus 2 is prime number? We will check using pyn function which we have defined. So now comes the how will we be writing code for the pyn? How we will be creating the function pyn? Now let's come to the coding part. How we will be writing the function pyn? Okay, we know that the pyn pyn function will return the integer value as an output, 0 and 1. So its range will be integer. So the data type of pyn is integer. So we have to define the data type before with the pyn function, int pyn, and it's what will be giving as input. We will be giving integers as input. So int m. So int z is equal to 0. We have already given z is equal to 0. We have given the value of z is equal to 0. If m is prime number, then z's value will not be updated. Z's value will remain 1. Sorry, 0. If m is composite number, then z's value will be updated from 0 to 1. So at last, pyn function will return the value of z. Now, based on the conditions of m, z's value will be updated or will not be updated. So if m is equal to 0, we know that 0 is not a prime number. So we will update the z's value is equal to z plus equal to 1. That this notation means z will be equal to z plus 1. Z's value will be updated to 1 because z was initially 0. Else if m is not equal to 0, then we will check whether m is divisible by any number less than equal to m by 2. We know that if m is a composite number, then there will always be a factor of m lying between 2 and m by 2, both included. So we will how we will check? We will check using for loop. For int I is equal to 2, we have initialized the value of I is equal to 2, and we have set the condition on I that I has to be less than equal to m by 2. If m modulo I, what does modulo means? Modulo basically is the function which returns the remainder. When m is divided by I, it will return the remainder. If m divided by I gives remainder 0, that means m is divisible by I. So there exists a factor of m which is I, and we know that i's value will be between 2 and m by 2. So that if m modulo I is equal to 0, that means we have to update the z's value. So z's value will be updated to 1, and we are using break because if once this condition happens, then this will break the loop. That means i's value will not be updated to I plus 1. It will not check for the I plus 1, because once we have found even one factor, that means we know that m is a composite number, and that was only our aim. If m modulo I is not equal to 0, that then what what should be done? Then nothing should be done, but i's value should be updated to I plus 1. That else nothing will happen. And at last it will return the value of z. If m is prime number, then there will be no factor of m between 2 and m by 2. So it will execute, it will every time it will check m modulo I, and it will not be equal to 0. So nothing will happen, so that value will remain 0, so it will return 0 only. Coming on to the next part. Now since we have defined the r function pyn, which will be returning value 0 and 1 depending on the integer m, now we need to write now we need to use check whether a given number is twin prime or not using our function pyn. Okay. Now int main, int a, cout, please enter your number. This cout will write, cout means it will be printed on our screen. So in a, user will give his input integer a, and these all will be executed in one line. Please enter your number, and you will be writing your input in the same line. Cout endl. Now all other things will be executed in the next line. If pyn of a is equal to 0, that means a is a prime number. If a is a prime number, then we will check for a plus 2 and a minus 2. First we will check for a plus 2. If pyn of a plus 2 is equal to 0, That means a and a plus 2 are both are prime numbers. So a and a plus 2 will form twin prime pairs. So what will be the output? It is twin prime number A. Hmm. If a pyn of a plus 2 is not equal to 0, that means a plus 2 is a composite number. Then we will go for a minus 2, whether a minus 2 is prime number or not. So if pyn of a minus 2 is equal to 0, that means a minus 2 and a now will form the twin prime pair. So it is a twin prime number. Now if pyn of a minus 2 is also not equal to 0, that means a is prime number and a plus 2 and a minus 2 both are composite number. Then now from this, what can we infer? That a is a prime number, but a is not twin prime number. So what will be the output? It is prime number, but not twin prime number. This is inside the domain of this if this condition pyn of a is equal to 0. Now if pyn of a is not equal to 0, that means a itself is not a prime number. So how can it be a twin prime? So it will return it is composite number, hence it cannot be twin prime number as an output. Now thank you for your patient hearing. I would love to see you in some next time. Thank you.